Hey everyone, good morning and good evening. Okay, let's start with today's session. Let's see what exactly we are doing today. In the meanwhile, anyone has any questions? Anyone tried doing Git or Talisman last week? Anyone tried? Pawan, Kishore, Satish, Guy, Bhagya?
Yeah, Satish. Yeah, Rohit. I did actually.
So any issues
I
with
don't
this?
have any issue. No, I don't get any issues in talisman wise, and I when I do pull request, I'm not able to find out exact differences. We have merge types 4, right?
Correct.
I'm audible.
Yeah, you're audible for sure.
So we have four types of merge types, right? Scratch merge and basic merge and rebase fast forward. I'm not able to find out once merge is completed the exact differences.
Don't worry, we haven't covered that. I'll cover that today. So don't worry about that, Kishore. Good. So,
Okay.
so what?
Apart from I'm at good.
Great, Kishore. Great. No problem. Okay, so good to hear that. Let's move on to the other topic. Today we'll start with Azure Repos, guys. So, if you guys remember, we have created one project, not this account. Let's switch to a different account. Okay, I think Ragul has joined today. So Ragul, please sign in to dev.azure.com and even sign into Azure portal, that portal.azure.com, using the
Okay.
same email IDs. If you go through my previous videos, you'll find out things. But for now, this is the account dev.azure.com. So this is Azure Repo is the new topic which we are covering today. So it's not, we have not done it yet, but just sign into dev.azure.com and Azure portal, that's Azure Cloud, using the same email IDs. Okay, create a free tier
Oh,
account. Okay, if you already have a
okay.
free tier account, then pay as you go will also do, because whatever services we launch that comes under free tier category. So don't worry, we will not get charged much. Okay.
Okay, sure. We'll try to create new account.
Yeah,
Okay.
and let me know if there's any issue. I'll help you out on that. Okay. But if
Okay,
you
sure.
go through the previous recordings, you will find out everything.
Yeah, that's fine. Okay, thank you for that
No,
information.
no problem. Rahul. Okay, guys. So last time we talked about Talisman. We pushed our changes, our local changes. This was a local change. This is a local repository which we have created, which we have pushed into a remote repository. So this was a project which we created, DevSecOps 1, and in this project there is a repository which we created, that is DevSecOps 1. Okay, and if you see, all our files is right over here. So today we'll talk about remote repository. Now whatever we did using the command line, what all things we did using the command line, we did create a branch, we did a merge, we did a cherry picking, we did a revert, all this thing we did through command line. Now the same thing I'll be replicating using GUI. GUI is nothing but graphical user interface. So using this interface of Azure Repos, I'll be doing the exact same thing. Does it make any difference? Yeah, command line, if you are very well versed with command line, you can do it on your local. That is something you are doing it on local. Now if you do it on the portal, so directly on the portal you are making changes, okay, which you should not permit anyone firstly. But yeah, the PR and everything will be created directly from here. One important thing to note, whatever the PR concept I'll be showing you, it's the same concept remains with GitLab and GitHub. The only difference will be the GUI will be different over there. So if someone asks you, are you aware with GitLab or GitHub, you know the working of GitLab and GitHub also. Don't say no that I don't know. Because whatever I will do over here, the same thing you can do it in GitHub and GitLab, Bitbucket also. The only thing will be the naming convention may differ, the GUI may differ, nothing else. The concept, the backend concept, it is using Git, and everything remains as it is. Okay. So let me introduce Azure Repos. This is nothing but it's a remote repository of Azure. It is using Git in the backend. Azure uses two version control. It uses Git and it uses TFVS, that's Team Foundation Version Control. Okay, so it's Team Foundation version control is more of centralized version control. If you guys remember the difference between centralized and distributed, wherein Git is a distributed version control. Okay, so as of now we'll focus more on Git. And so when I created this project, like when I was creating a new project, if you guys remember, in the advance there was an option of selecting the version control. We selected Git. So Git is by default. So whenever you create any project, Git gets created by default. Don't worry about the work item process. This is something we haven't covered. That is the next topic after Azure Repos. Okay. For now, we'll select on Git, and this is something we have created. Now this is the project based out of Git. Now by default, whenever you create a project, the only branch which gets created is the main branch. At the top you see a main branch which got created. Okay, and if you want to create a new branch, this is the drop down. You can create a new branch directly from here, or you can come to the branching section and you can create the branch from here. Okay, now when you create a new branch, what we were doing when we were creating the branch from the local, so whichever branch you are in right now, the new branch will be created based out of that branch. Correct? Everyone remembers? Whichever, like if you are in main branch, the new branch which you create will be created based out of it. If you're there in the feature branch, and if you're creating any new branch, the branch will be created from that branch. Remember, over here you have an option to select which branch you want to create. By default you will see main branch. Okay, the reason by default it's showing main branch is because there is a tag of default over here. Because of this tag, if anyone cloning this branch, this main branch content will get cloned. If I'm cloning this branch, this main branch will get cloned on my local. Later you can switch to a different branch and clone the other branch also. That's a different story. But initially the main branch will get cloned because this is the default tag which is there. Now if I change the default tag, now make the develop branch as a default. If I create a new branch again, see, it will be created based out of develop branch now. So this default tag, what you see guys, it's very important. Keep that in mind. It's not just for namesake. This is very important. It has a very good advantage when you're setting up branching and merging policies. So what did I say in my branching and merging policy video? That if a developer is creating any new branch, that should be created out of which branch? Guys, if any developer is creating any new feature branch, if he wants to start working on any new feature, which branch he should clone it from? Anyone?
Default.
Default.
From development branch.
Yes, perfect. So from your development branch, it should be cloning. So how do you force a developer? By setting development branch as your default branch, correct? So again, one way of setting policies. So this is how you will be setting up your default branch. Okay. Now there's one more tab, compare. I'll talk about that later. But for now, this is how you will be creating branches. So in my mine section, you can see your branches. In all section, you can see all the branches. In stale is basically if any branches is not getting used for more than 90 days, that comes into a stale category. Okay. Any branches which is not been used for more than 90. When I said use, what do I mean? I mean no commits happening in that particular branch. So that's come under stale category. Okay. So this is about your branches. This is how you will be creating branches. Now, if I make any changes to my develop branch, let's go and add something to it. I'm just making direct changes guys just to show you. Let's create a new file, test file, test.txt. Let's edit something. Hello world. Okay, now this is again the same thing. Now I've added the file. Now this is the comment which I'm adding. This is automatically it's taking, and the commit is happening on the develop branch. So two commands together it's happening, git add and git commit. So go back, start relating things from the command line, whatever we did. So whatever we did from the command line, if you want, like whatever I'm showing right now, if you want to do the same thing through command line, then you need to create the file, do a git add, then do a git commit. Correct guys? Hopefully it's making sense. Now it is committed. Now if you go to the branches, now see the importance of this compare. Now do you see this number behind and ahead? 10. This is the number of commits. So you're doing a comparison with your develop branch. Okay, so your development branch has one commit ahead, like because the commit which we did, that we did in the develop branch. Okay, so that develop branch is one commit ahead. So that is the reason, and others are one commit behind. So your main branch is one commit behind, and your release branch is one commit behind, and your develop branch is one commit ahead. So this is the commit comparison which is showing you behind and ahead. If I make changes in release branch now, it will be 1 1. It will be one commit ahead and one commit behind. If I go and make one more changes in develop branch, well, for example, let's go inside the develop branch and let's edit this file. New API key. Put whatever you want. Okay. Added a new API key. Again the changes in the develop branch. See, it went 2 2. So this is again for your understanding. If you what exactly is the branch, where exactly is the branch right now, this is for your understanding, you can see it. Okay, that is the importance of default and compare. So basically if you ask me, the comparison should happen with the main branch, not with the default branch. So if you want to change this way, you can do the comparison with the main branch. Now the main branch, if your develop branch is ahead 2 commits, this is how you can do the comparison. Okay, now if you want to compare these two branches, what exactly the difference is, if you want to know, you can click on compare branches and you can see comparing develop with main. These are the files, two changes which is not there in the main branch. That is the comparison what you're doing, develop with main. Okay, again which command from local you can do the same thing, git diff. Okay, the one which you're doing, you're using this GUI, the same thing you can do it from the command line using git diff command. Keep that in mind. Okay, deletion of branches, you can simply go and delete the branches if you want. I'm not deleting anything for now. I'll be creating one more new branch. I'll name it as feature branch because I need couple of branches to showcase. Now this is your commit ID. This is the author who has made the changes, and the email ID and the author who has just made the changes, and this is behind ahead. This two thing is status and this is pull request. Status is basically if there is a build and release pipeline associated with this commit, then that status will be visible over here. So in future when we do the CI/CD part, at that time you'll see the status popping up over here. And the pull request is nothing but when you create a PR. What exactly is a PR, we'll talk about that in a bit. But for now, if you create a PR, then it will be visible right in the screen. Okay, so this is about your branches. If you come to the file section, it will show you all your files. Okay, and this is your commit history. So this commit history is basically only for your develop branch. If you want to switch and see the commit history for your main branch, You can see it over here. Similar commit history will be visible over here in commits. Okay, and if you go to the develop branch, you can see the commit. You can see what has been made. If you go inside it, you see more details about the commits, your file name at the left hand side, and you can see you can change the view. This is inline view, so whatever has been added, it is showing beneath it. But this inline view will more confusing, guys, when you in reality, when the piece of code which you're seeing, it is more than 500, 600, and there are multiple changes. This is very confusing. So the best view which I can think of is side by side. Side by side view is the best view. This is the previous version, this is the latest version. Okay, this is how you can view two things, previous version and the latest version. In the latest version, you can clearly see this is what was done. So this is how you will be able to see all the commit history. At the top, this button you see on and off, this is nothing but this is graph. And this graph is very important, guys, to understand what exactly was done, what type of PR was raised, how the commit has merged and everything. This graph, this is the linear graph which is showing right now. I'll show you what is linear, non-linear graph, but this graph is very important. This is your commit which it's showing. If I off it, then the graph is gone, but always use this graph to understand the flow. I'll show you the graph, the importance of graph in a bit, but now always use this graph. Okay, pushes is nothing but whatever you're going, again a type of way of checking the history. So this is more from the branching perspective, what all things were pushed to branch develop. So you can see the details over here. These were the things which we pushed to develop branch. And you can toggle around to any other branches also, feature branch and from the top itself. Okay, your tags, as if now there's no tag, your tags will be visible over here. If you give it a tag, you create a tag, your tags and everything will be visible over here. Okay, so till now this is just an overview about Azure Repos. Okay, now the very important part in Azure Repos is PR. PR is nothing but pull request. So how do we merge, like from the local, like if you see in my develop branch, I got two more new commits which is not part of my release branch. So if I want to do the same thing from my local, what exactly we were doing, if I want this changes to be pushed into my release branch from the local command line, what exactly we need to do if I want to push all the changes to my release branch? Anyone? What is the command we run?
Git merge.
Git merge and release, correct? That is the branch name. You have to be in the develop branch, you have to be in the release branch, then do a git merge, correct?
Yes.
Perfect. Now the same thing if you want to do in Azure Repos, you need to create a PR. PR is nothing but it's a form which you need to fill in. You need to give the source and the destination, and then you need to go and merge it. Let me show you. So if you come down to the PR, that's a pull request. This is the place wherein you can create that form which I was talking about. So all your own PR will be reflected over here. All active PRs will be reflected over here. All completed PRs and abandoned PRs will be reflected over here. So let's go and create a new PR. So it's a new pull request. What is my criteria? From develop to my source is develop and my destination is release branch, correct? Now many of you will say why the main branch was reflecting, because you're doing a comparison, that is the reason, and I was into main branch if I'm not wrong. Okay, so that is the reason. So you can select the source and destination from develop into release, and if you see this toggle button, if you want to switch, the source and target. From release into develop, there's nothing to merge. From develop to release, there are two changes to merge. What are those two files? File 3, this is the change which we did, and this is the text file what we have added. These are the two commits which will get merged. Okay. Now you can give your description, merge to release. Give your description, or if you don't want to give your description, you want to copy the same commit. Whatever messages are there in this, you want to copy it, click on add commit messages. See, this will get added automatically. Reviewers and all, just keep it aside for now. Work items to link, keep it aside. This tag is basically if you want to know if it's a what type of change, it's a production, database, app, web app, front app, whatever it is. So you can name it. Like if it is database, just tag it as database. A tag will be created. And this is the form you filled in. Click on create. Done. Now this is a complete view, overview what you are doing right now. It is checking automatically if there's a merge conflict. Merge conflict is basically if you're making changes, two developers are making changes to the same file. Okay, and there's a conflict. At that time you'll get this merge conflict error. Like suppose I am the developer, I made changes to one of the file, and take an example of Bhagya is also making to the changes to the same file. I did the commit first, and when Bhagya tried to do the same commit, she's getting a merge conflict. That there is already a change available in that same line. So Bhagya needs to see if my changes can be overridden. So she needs to talk to me first, whether I can remove your changes, or I need to go and make the amendment again. Then Bhagya needs to pull the change again, get my change fetched first, make a new change, then commit. So merge conflict this is how we will resolve the merge conflict. Okay, keep that in mind. If I say no, you can override my change, that's okay. So Bhagya will simply take her changes and she will push it. So my changes will be deleted in such cases. So I'll try to create a merge conflict and I'll show you how to fix it later in this course when we start working with Visual Studio Toolkit. At that time I'll show you that. So don't worry, just remind me to demonstrate merge conflict. At that time I'll try to fake a merge conflict, and try to show you how exactly in reality we'll fix the conflict. Okay, so it does do a check if there's a conflict. So there's no conflict, so we are good. These are the files, updates and commits. Okay, now if you want to, and this is what the tagging you did. Now all this comment box and everything is used when you do when you have a approval process, when you have a code review process in between. So in the next PR I'll show you all these approval policies and things like that in the last PR. Okay, for now just keep it as it is. And if you want to complete, everything is looking good. If you want to complete, if you click on complete, this is the different merge type which you will come across. There are 4 types of merge type which you come across: merge, no fast forward, squash, rebase and fast forward, semi-linear merge. Now this is very important to understand. Let's go and understand the first merge type, that is non-linear, history preserving all commits. Let's go to PPT. Okay, so the first merge type, it is a default integration strategy in Azure Repos, GitHub and most other Git providers. So whatever you're doing right now, it's the same strategy in GitHub, GitLab, Bitbucket. And this is default. Why it is default? What is the benefit of this merge, no fast forward? All individual commits are preserved as is and a new merge commit is created. Okay, let me explain this with an example. Let's cancel this for now. Open a new tab. What exactly I'm doing? I'm merging it from develop to release. Have a look into the develop branch history. Let's go to commits and see it. Okay, so your develop branch has 2 new commits: added text.txt and updated file 3. And if you go to release, The release branch does not have that history. Make sense? Now what this PPT is saying, all individual commits are preserved and a new merge commit is created. So what does it means? When the merge will happen, these two new commit which you see under develop, added test and updated file, this commits will be pulled as it is and it will be placed on top of this API keys, plus it will have a new merge bubble created, signifying that there was a new commit added. So what is the importance of this? It is preserving your history first. You have your complete history, plus on top of it you have a new merge commit showing that this is the final commit. Okay, let's go back to the PPT. This strategy is helpful because it illustrates exactly how a developer worked on a pull request, how the pull request was created, including each individual commit along the way. Now focus on this graph. Now this is your actual commit. When you cloned your repository, remote repository, when you cloned it or when you pulled it and you started working on your commit, this is how your commit is evolved. You did two commits. One commit, this is your second commit, and this is your actual commit which is going on. Okay, so when you're done with your work, this is the blue line is your work. When you're done with your work, what you do, you merge it with the main. So both your commits are getting preserved. This one commit is getting preserved, your second commit is getting preserved on, and this commit, the bubble which you see over here, this is the new commit which is getting created, and this new commit has all the changes. All your files will be clubbed over here. Along with, you can see the history. You can go in the back and you can see what exactly was done. That is merge, no fast forward. Let's see it in practical, you'll understand more. But keep this in mind, release branch does not have that two commits which we have it in develop branch. Now let's go and do a complete. Ignore this for now. Post completion, complete associated work item. So if you create a work item, if you want to close that work item, then you can check this box. For now, just ignore it. Let's do and see this graph how it will. This new two commits and there's a new pointer getting created. Completed. This is done. Do you see this graph, guys? This was the previous commit. Now this graph is showing you there are two new commits, added test file, and this is the new merge commit got created. You see merged PR1, and if you go inside this, you'll see both the files. In the final commit which you see over here, you can see both the files, and along with you see these two files, added file 1. So what is the benefit? You're preserving the history as well as you're creating a new merge commit. So you get to know by now see the importance of graph. You can, by seeing this graph, you come to know that this was a previous commit, and from here there's a PR created, and the PR, this is the two commits which was pulled by the PR, and this is the final pointer. Okay, and this is now the pull request is showing one pull request 1. This is the first pull request which I have created. That is the reason the numbering is given over here. That is merge, no fast forward, and 85% of time this is the this type of pull request you will be creating. Makes sense? Anyone? Any questions over here? Any doubt? Kishore, now you understood the difference when you do a merge, no fast forward? Anyone? Any doubt?
Yes, Rohit, clear.
Very good.
Can you can you go through it one more time? I think I'm lost.
No worries, don't worry. Okay, so merge no fast forward is the basic commit. By default, this is the commit what we did. What we do, it's a default integration strategy. What is the benefit of this commit is all your history. So Git is all about history, guys. Keep this in mind. If you have the history, So history is basically the versions which you're creating. So Git is all about history. Preserving history in Git is very important, because by seeing the history you'll come to know how exactly the development has evolved. Okay, now if someone is working on an application, this is the text file and things we are adding, it is not making more sense, but just imagine from the application perspective, if someone is working on an application, is working on a feature, and he has done a commit, okay, and the commit was deployed into production. Now the production has some issues. How do you backtrack who made that changes? Is by the Git history. You can go to the Git history, see who was the developer who made the changes. So Git is all about preserving history. Okay, so when you have so in this commit type, you are preserving history firstly, and secondly you are creating a new merge commit. So you have the backtrack, you can easily go and see who has made what changes. You have all the histories, plus on top of it you have new commit getting created. That new commit will have all your changes. Okay, so that is what we did. If you see this two commit which you see, this is basically from develop branch. If you go and see the develop branch, after the API keys, added test and updated file 3. So these two commits was picked as it is, no changes, to the release branch. This two commit, plus on top of it we had a new commit created. That is merge, no fast forward commit. Do it by yourself, then you'll see the difference. Okay.
Yeah, Rohit, one question.
Yeah. Tell me.
If we like from feature to release, if we do the same thing, even can we see this graph like that? Let's say from feature to develop. Now we are doing from develop to release, no?
Yeah.
This merge.
Yes. Now
Let's.
I cannot do it to feature, because if you see the develop to feature, it has same set of changes. So there is no, if you try to create a PR, let's try to create a new PR from develop to feature, there's no difference. It's the same thing.
Okay.
But we can definitely do to develop to main. There are two changes again. It's the same thing. Now if you go and see the develop and see the difference, see the develop, it got two changes, and if you see the main, it doesn't have that changes. Now if I create a PR using the same merge type, the graph will remain the same. Let me show you, but this time I'll not do the merge to main. This time I'll not use the first type, but this time I'll use the second type. I'll use the squash one. Okay, one important thing, it's non-linear histopreserving. What is non-linear? The straight line what you see right now, this is linear. Now if you go to the release branch, this was not a straight line. This is a non-linear line. So that is the reason it is called as non-linear history preserving. It is preserving your history commit. Okay, so keep this in mind. Now the second one is the squash. What it is saying, linear history with only a single commit on the target. Now this is very dangerous one. Why dangerous, I'll tell you. Squash commit is in squash commit, each pull request becomes a single commit, and there are no merge, just a simple state linear history. What does this mean? What will happen? What squash commit will do? You got, let's go back to develop. You got two new commits in your develop branch, and you're pulling the request into the main branch. And if you use the first commit type, so what it was doing, it was preserving history, a nice looking history, and plus it was creating a new bubble commit, by which we come to know, okay, the PR was completed over here. That is what the idea was. Now in squash, what's happening? This two commit will get squashed into one single commit, and in the main branch you will see a new commit getting created. So squash will not preserve any history. It is non-linear. It is linear in nature. It will be a straight line. It will not preserve any history for you. In a simple term, no history preservation, and it will be a straight linear graph. What it will be creating, but it will have all your file content. So nothing will be removed. The only point is the history will be deleted. And if you want to backtrack in the main who has done what, you cannot backtrack. Okay. When to use squash, I'll talk about that later. For now, individual commits are lost, which is best for team that uses fix-up commits or do not carefully craft individual commit. I'll talk about all this later. But this is how you have cloned. Your work has evolved at the bottom. But when you are doing a commit, when you're doing a merge, all this work is deleted and a new commit is getting created over here. This is what this graph is talking about. Okay. So in squash, whatever new commit you see over here, edit, test and updated file and all will be deleted and a new commit will be created in main branch. Let's see how it does. Done. Now see, this was developed prior. Okay, now if you go back to main, do you see those update now? Added text and updated file. Do you see those things? No, nowhere. The only thing you see, the PR2 and a dot. A graph is a dot. There is no graph created. Merge to main. By seeing this, you'll come to know who has done what was the changes. No. When you go inside it, you see both the files, but your files are not getting deleted. Your contents are not getting deleted, but your history is gone. Now the question arises: when do we use this type of commit? Wherein we are not preserving history. Anyone? Any suggestion? When do we use this? Guys, if anyone has used it in the company, let's open the branching and merging strategy diagram which we have gone through. Now what we were doing, that from the release branch, wait, do I have any? Wait, let me open this in Paint. Okay, from release to main, if you guys remember what we were doing, we were creating a PR and we were pushing all the release code into the main branch. This was when the release was completed, your production deployment was completed. Then from there to this main branch, we were pushing the code. Correct? This is the time where history preserving is not important. Why not important? Because when you do the cherry picking from develop to release, at that time you have already preserved the history. This is the place where you can use the first merge type, no merge. You need to have the history, complete history. Who was a developer, what were the changes, what is the PR he has raised. All this will be preserved when you're moving the changes from develop to release. But once the changes are there in the release branch, you already have the history in the release branch. You have everything, whatever you need. Now unnecessary, why do you need your main branch to have all those history? Because if you have all the history, this is how the graph will look like in your main branch. All such graphs, all this non-linear graph will be visible in your main branch. Why do you need this? Still loading. Not required. In reality, if you ask me, it's not required. Because as if now it is looking very simple, but in real time, if you go, you will see multiple commits, 100 of commits, and you'll have all the non-linear graph it will be very difficult to understand what exactly happening. So when you already preserving the history in your develop branch and release branch, why do you need the same history in main branch again? Why do we keep the main branch? Main branch is what? Used for keeping your production code, keeping the golden copy of your code, correct? That is what we are using main branch for, correct? Then if you have that thing in your mind, then main branch will not require history. You already have the history in release branch and develop branch. If you want to go and backtrack, you can go and see the previous branches to backtrack. So in the main branch you don't need the history. So in such cases, when you're creating a PR between your release branch and main branch, you can easily use squash commit over here. Squash commit will squash all your commits history, and it will just create one single linear commit for you. Now interview question. The interviewer says there are two branches, develop branch and release branch. In my develop branch I got 100 of commits. Now I want this 100 commits to be pushed into my release branch, but only one condition. I don't want unnecessary commit history, but I want all the changes. So understand the condition very well. I got 100 commits in my develop branch and I want to push all this 100 commits into my release branch, but I don't want unnecessary history. I want all the files and all the content. How do you do it? Squashing. This example will be more relevant when we talk about that a developer has created a temporary branch, and while doing the development, he has done n number of commits. Now you need to push all the changes to the develop branch. So when the developer was doing the development, it is in his local branch, so no one is using that branch. It is local branch. He can do whatever commits he want to do unnecessary commit, it's totally fine. But when he is pushing the changes to the develop branch, which is used by other developers also, we cannot push unnecessary commits, unnecessary history in the develop branch. In such cases also, from this location to this location also, you can use squash. Just imagine if a developer, just for making a minor change, he did 50 commits. Will you allow unnecessary 50 commits into your remote develop branch? No, you should not do it. Your develop branch, your release branch, your main branch is something you are taking care of. You guys are taking care of. So yeah, in such cases, you can make use of squash commit. So that is the reason I said squash commit is a kind of a dangerous commit. You need to use cautiously because it is deleting your history. Okay, so you need to know, be 100% sure where to use it. Okay, because once you do a squash, your branch history is gone. Okay, any questions over here with squash? Anyone? Any confusion? No questions? Make sure to go and practice the same way I'm doing it right now. If you do it this way, you'll be able to understand how the commits are evolving. And let me tell you, the first commit which we did, 85% of time that is the commit you'll be using it. Next 10% of time we'll be using squash, and the next two commits which you will see, the rebase and fast forward and semi-linear, this is hardly you'll be using it. Okay, but let me show you that also. Now how do I create a PR? From develop to even if I create a new branch, okay, let's create a PR. Yeah, I need to make changes into develop, more changes now. Let's go and make more changes into develop branch. Let's create a new file, file 1, added file 1. So I'm creating new commits in develop branch, guys. Let's create file 2. Added file 2. Okay. Again, two more histories I'm creating in my develop branch. Okay. So I got two new history, file 1 and file 2. Now let's create a PR. Now this time I'll create a PR between develop and feature branch. Develop and feature. So two new files, two new commits, perfect. Merge with into feature. Okay. The third type, rebase and fast forward. Rebase source commit onto target and fast forward. Now this is, you need to understand what exactly is rebasing means first. Let's go back. Okay. Rebase will take each individual commit in the pull request and cherry pick them onto the destination branch. What does this mean? When this strategy is used, history is straight and linear like it is with Squash, but each individual commit is retained. Now in Rebase, this is a combination of merge no fast forward, the first commit, and Squash. Now in this, what will happen? Your history will be preserved, okay, but there won't be any final commit created and it will be squashed. Now what's happening? This is your work. This is how your work has evolved. Both this commit, these dots which you see, both your commit got preserved over here, but no additional commits are getting created. What was happening in the merge fast forward? There was a new commit getting created. What was happening in Squash? There was a new commit getting created. But in this rebase, what will happen? In a simple layman term, this these two commit, added file 1 and added file 2, will be simply picked from here and placed on top of this updated file 3. Those two commits will be simply picked and placed on top of this point. That's it. That is rebase fast forward. It will be linear commit, history preserving commit. Okay, so this strategy is used in straight and linear like it is with Squash, but each individual commit is retained. Nothing will happen. The only difference you will see is from develop, these two commits, the first two commits which you see the graph, it will be simply picked and placed on top of your feature. Your history is preserved, no new bubble is created. That's it. So this commit is a combination of merge no fast forward and Squash, but the only difference is it will not have any new commit getting created. See the difference. Let me complete this and show you the difference. Done. Refresh it. Do you see in the feature branch, it's a pull request 3 which we have created. Updated file 3 was the old commit, and now if you see, added file 1, added file 2. That's it. What has happened? Simply those two commits was picked and it was placed on top of the destination branch, and it is linear. That's it. That is what rebase is all about. Rebasing, if you get a question, what is git rebase? So git rebase is nothing but it takes your source commit, differential source commit, and puts on the top of your destination commit, target branch. That's it. One important thing what rebase does in the backend, guys, it rewrites your commit history. You'll not come to know the commit ID and nothing will get changed, but your indexing, if you go at the indexing level, it rewrites your commit history. So if you're working in a public domain and if you're working in public repository, most of the cases rebasing will not be allowed because it is going and playing around with your index file. Wherein other commits like merge, no, fast forward and all, they are simply picking your commit and placing on top of it. So if you go in more technicality, rebasing in the backend will make changes to your index file also. So in most of the cases, hence rebasing is not allowed. Okay. Now in this PR, what is happening? Very simple, very straightforward. It is simply picking the commit from the source and putting it on top of your destination, your target branch. That's it. No new commits are getting created. Simple, straightforward. Okay. Any questions over here? Now I can have one more PR created. We have one more merge type, that is semi-linear one. So I'll do it from develop to release branch. From develop to release branch, we got again these two files, file 1 and file 2, and this is the commit what we have. Okay. Merge to release. Okay. Now the fourth one is semi-linear merge. Okay. So semi-linear merge is nothing but it will rebase source commit onto target and create two parent merge. What does that mean? Semi-linear, it's a mix of rebasing and a merge. First, the commit in the pull request are rebased on top of the master branch. What do I mean by this line? Commits or pull requests are rebased on the top of the master branch. That means your source commit is simply picked and placed on top of your target branch as it is. That is what rebasing means. Then those rebased pull requests are merged onto the destination branch. Okay. So it's a combination of rebase plus merge, no, fast forward. This is the combination. This strategy is best used for retaining individual commit and viewing how the work has evolved, but instead of just rebasing, a merge bubble is shown so that you can immediately see the work in your each pull request. Okay, so in rebase semi-linear, it's a semi-linear merge commit which you will come across. Now this is how your work has evolved. All your commit, and this is how your work is done. So this too is your previous history along with a new merge bubble is getting created over here. Rebase plus a new bubble. So same, just imagine rebasing. How you had done the rebase, the source commit is getting picked and placed on top of the destination commit along with a new merge bubble is also getting created. It's very similar to no merge. It's very similar to this one, this type. You will say this is exactly the same, but it's not the same, guys. In reality, what did I say? In rebase, the index file gets updated. Okay, and over here in no merge, no, fast forward, we don't update any index file. Now if you do say semi-linear, it will look exactly the same. Now let me show you the history first. Go to the release branch, where exactly the release branch is. This merged, correct? And what are the two commits we are picking? File 1 and file 2, correct? Now let's see. Done. See this graph. Do you see this graph? This was the previous parent commit. Now if you see, edit file 1, file 2, and a new bubble got created. Now see this inversion which has happened, and the inversion over here. This is a clear depiction that this is merge, no merge, and this is semi-linear merge. In the semi-linear, the only difference is we do rebase. Rebase is basically, if you go into technicality, it plays with your index file. Okay, so hence you need to, but if you see from the graph level, it look like exactly the same. The only the inversion, if you remember the inversion, there's a flip at the bottom if you see, and at the top if you see there's a flip. It's two different types of merge commit which you have done. Which one to use when, that is something we can possibly discuss in this graph. As I said, temp branch to develop branch, mostly I'll suggest squash. Develop to release branch, it is you should use the first type, merge no fast forward, because you should preserve your history over there. History is very important, guys. Which developer has made what changes, you need to preserve it over there. Release to main, it should be squash, but again up to the project you're working with. In the project, if they say no, I want to preserve all the history in the main branch, it's okay. You just create the first merge type, and then the final commit bubble what you see, just tag it whatever tags you want to give. Okay, now from develop to UAT feature, again the same, merge no fast forward. Rebase, semi-linear, up to the project requirement. If they are okay with updating the index file and all, then you can use the other types, rebase and semi-linear. That is the reason I said very hardly you will be using that merge type. If you have any such project requirement wherein it's okay to play around with your history, then at that time it's okay to use it. But 95% of time you'll be using merge no fast forward and squash. That's it. Make sense? Any questions? Okay. Now if you want to tag it, now suppose let's go to the main. This is the final commit which you did, and you want to tag it with any type of versions. So multiple ways to tag. One you can go inside it, and over here there's an option to create tag, and you can just name it as major version 1.0, something like this. Okay, you can just tag it this way, or you can even go inside this tags. Inside these tags you can create a new tag, and you can select the branch and you can tag it. It already exists, that's why it's giving an error. But this is also, so if you do it this way, automatically the latest commit will get tagged. Like suppose 1.1, and I'll just have develop. So whatever latest commit you will find it, that will get automatically tagged as 1.1. Let's go back to your develop branch. Commits. Do you see it got tagged 1.1? And if you go to release main branch, you will see tagged 1.0. This is how tagging works in Azure Repos. Okay guys, so these are the 4 types of merge. Let's do a quick summary. There are 4 types of merge which you will come across. Merge no fast forward. This is the default merge which you will find across multiple domains, GitHub, GitLab, Bitbucket, and many more. This is the default. This is the merge type which will preserve your history. All individual commits are preserved, and a new merge commit is created, which will show you the workflow, how exactly the commit has evolved. The second is the squash one, which is a dangerous and use it cautiously. It will squash all your previous commit history, and it will create only one single commit. All your history is deleted, only one new single commit is created. Rebase fast forward. Rebase is basically what it does, it will take the commits from your source, differential commit from the source, and will put it on top of your target branch. That's it. No new merge getting created, nothing is happening. It's simply preserving the history. Okay. Semi-linear is a combination of rebase and merge, wherein all your history, all your source commits are rebased. What do I mean by rebased? All the source commit is picked and put it on the top of your target branch, plus a new merge bubble is created. That is what semi-linear commit is all about. So these are the 4 types of commit which you will come across when you start working with any type of these are the 4 types which you will find out. In GitHub there are again 2 types, on GitLab has additional 2 types, but definitely the first 2 types which I said, squash and merge, you'll find it everywhere. Okay, so that's it from the PR. We have couple of more topic left with Azure Repos, such as how do we cherry pick, how do we revert, and things like that. That is something we'll do it tomorrow. For today we'll stop over here, and I'll suggest whatever way I have showed you by creating PR and all, do the exact same way. See the difference yourself, like when you do a merge, no fast forward, what's happens at the graph level. When you do a squash, what happens at the graph level, and when you do a rebase. Okay, and the same questions, like whatever we're doing, the same questions will be asked during an interview, but in a different way. Make sure to remember in which type what to do. Okay, they could ask any question that I want to preserve history, and I want to see the flow also of the commit. How do we do it? So remember, they're talking about merge no fast forward. Okay, that's the default commit what we do every time. Okay, that's it. Any questions, guys? Let me know before we wind up the call.
Yeah, Rohit, one doubt here. Hello.
Yeah, listening.
Yeah, there is a stale branch we have, right?
Correct.
As we discussed, we didn't use 3 months. It's automatically going to be deleted, or how?
No, it will not
We
be.
need to automate.
No, it will not be deleted. It will go in stale category. It will
Okay.
not be deleted. It will come in the stale. So that is which will no longer tracks anything. So the stale branch is basically it's a remote tracking branches which no longer tracks anything. Okay. So basically what will happen, the actual branch in the remote repository has been deleted. So it comes as a stale branch. So if it's no longer used for a longer time, or if the remote branches of the stale branches got deleted and somehow this is still there, so it comes into stale category. Okay.
Okay, okay, Rohit. And one more thing, any suggestion to to prepare for PowerShell script, any site or document?
PowerShell scripting. Okay, let's go through the course. I'll suggest if I get something, I'll share it across with you. Okay.
Okay, fine, fine.
Anyone else? Any other question, guys? A stale branch. I want to talk about stale branch also. It's also about local references. So wherein you have cloned something, like suppose there is a feature branch right now, and you have cloned the feature branch, but the feature branch you have deleted from the remote. So even that comes under stale category. So there are multiple categories in which your branch goes in stale. One is the branch which is not using for longer time. The second, when the local reference is deleted, even that comes into stale category. Okay. Okay, guys, just keep this in mind because this could be a possible interview question. What is stale branches, and what I don't know, like on what basis the question will be asked, whether from the local reference basis or from the duration basis. But yeah, that comes into both are from both will be under stale category only. Okay. Any other question, guys? Make sure to practice this because this is something you'll come across a lot when you start working with Azure DevOps. Do we have any questions? Any suggestion? Okay, okay. No problem. Anyone else? Okay. If nothing, then thank you very much. Let's meet up tomorrow. Let's continue with Azure Repos, and post Azure Repos. Let's start with understanding work item. Okay. Bye bye.